Today I'm gonna give you sort of a very brief impression of the work I did for my PhD, called the talk "Where Do Problem Spaces Come From?" on Metaphors and Representational Change. Matt already introduced me, so I don't think I need to say that much more. So let's start right away. Just a brief outline, so I'm going to give a little bit of theoretical background on problem-solving theory and metaphors, and a little bit sort of about the idea behind the study. I'm going to introduce the task that I used in my studies called Iterated Mental Paper Folding. I'm going to give you sort of a few impressions on a case study of two participants rather, and I'm going to finish with a few theoretical conclusions. Okay, so on to problem solving. So in cognitive science, we have this sort of long-standing standard model of problem solving already introduced by Newell and Simon in the sort of late 1950s. Which is this idea of problem solving as heuristic search in problem spaces. So the idea is that if you have some kind of task, you interpret it, you get some task instructions, which you interpret, given your background knowledge and perception of your environment and so on, you interpret it in terms of states and operators over these states. Then solving the problem is to search for a chain of operators that links some initial state that you're in to a state that fulfills some kind of goal condition. And usually you have sort of this kind of triangular shape, which sort of metaphorically indicates that you have this graphical space with a lot of sort of branching going on. So that kind of framework works very nicely and neatly for the kind of well-defined tasks that we also like for sort of reasons of experimental methodology, Towers of Hanoi, water jugs problem, cryptarithmetic, this kind of stuff. But if we look at problem solving in a sort of more general context, then we can ask the question, what should we do if it's not really clear how to understand a problem in terms of states and operators? In sort of psychological experimentation, we just sort of give our participants task instructions, which sort of very neatly explain to them how they should understand the thing. But in real life, that sort of hardly ever happens. And there was also something that sort of the early researchers in problem solving were quite aware of. And so Simon in the early 70s already wrote this paper on what he called ill-structured problem solving. And they sort of very cheekily said that, oh yeah, there are some additional processes that change the problem space to a more appropriate one sort of over the course of the problem solving process. But the question is, how does this happen? So how are problem representations constructed and, if necessary, changed? And there Simon has this nice magical box, which says there are noticing and evoking mechanisms, which sort of interact with the environment and our long-term memory, and which are supposed to sort of somehow then change our problem representations into more appropriate ones. And I hope that this already sort of sounds a little familiar to sort of analogy researchers here, because this is where I would suggest that analogies sort of play a quite important role in elucidating this process. So I'm using the term metaphors here that has mainly sort of historical reasons for how my project got started. I'm not sort of insistent on using that word in a specific way. I more or less mean sort of the consensual thing that we also in cognitive science mean with analogies, there being mappings between two conceptual and or perceptual domains, which provide structure to an as yet less well understood target domain. So there is this kind of familiar scheme that most of us will have seen in some form or other. We have a target that we are engaged with. We somehow encode it into some form of initial target representation, which reminds us of something. So there's a memory retrieval process where we can have sort of one or more candidates, and finally we retrieve some kind of source representation. So now we have both these representations in our working memory. They are aligned with each other, and if there is some kind of additional structure in our source representation, we can transfer that and modify our target representation and sort of give it some additional structure. And finally, we could also sort of generalize or schematize it, store it in long-term memory for sort of future reference. So that's kind of the very general picture that I guess most of us are familiar with. Onto the study. We developed this, me together with a couple of colleagues, sort of with the idea to investigate the first steps of understanding a very complex task domain. So it's an exploratory case studies of people freely working on a task for a prolonged time, so much less constrained than your typical sort of problem-solving study. In it, pairs of participants discuss a problem, which is sort of a natural form of interaction, and also sort of gives us, as researchers, a window into how they understand the problem, because we can look at that dialogue. The task starts out from a familiar physical activity, but representational change is ultimately required because of the complexity of sort of how you would represent the problem naively. And then I conducted in-depth qualitative analysis of video recordings, looking at the dialogue, the gestures, error patterns, and so on, specifically focusing on the metaphors they generated spontaneously when trying to understand this task domain. So what is it? I already said at the outset, I call it iterated mental paper folding. So in this task, people have to imagine folding a sheet of paper across alternating directions again and again, and they have to understand the geometry of the edges that are visible from each side of the folded object. So to give you an idea, we have an unfolded sheet. We fold it once in one direction, second time in the other direction, third time, fourth time, fifth time. And I guess you can already see sort of this becomes very complicated very quickly. And if you try to sort of understand the edges there in the fifth fold, usually sort of, you know, without having thought about it for quite some while, you just see sort of a mess of lines there. So let's look at it a bit more, sort of what do I mean when I say the edges? So this is like a more schematic depiction of the second fold. Can you actually see my mouse cursor, or am I?
Yeah.
Okay, great. Because, you know, otherwise, yeah, pointing wouldn't really work out. So, okay, there's this more schematic depiction of the second fold. And if we look at it from the back, for example, we see the crease that we just made. So there's just a single line. Below, because we alternate folding directions, we've just sort of folded the crease from the fold once before. So we have this kind of V shape. If we look sort of frontally into the fold that we make, we see this kind of double structure here, call it a double V. And if we look at it from the top, we see this nested structure. And if we look at it from the sides, we see sort of two rectangles that we conveniently ignore because they don't change. So why is this interesting? If you keep doing this, at one point you might notice that there's sort of an underlying generative structure. There's a recursive relationship between successive folds. So already you've seen in this picture just now, the crease from one fold gets sort of folded in the middle, becomes this V shape. There's always a new crease, but also sort of the complex sides have some form of interesting relationships. For example, this double side is always sort of folded along its middle to form the nested side of the consecutive fold, and so on and so on. You don't have to understand the details here. This is just sort of to give you an impression of the complexity that's involved. So what do people have to do specifically? Pairs of participants are asked to imagine cross-folding a sheet of paper and to discuss the resulting object and what it looks like until they are both fully agreed and certain. And then when they both can successfully imagine it, they are asked to plan, drawing 2D sketches of the edges that are visible from each of the sides. And only once, again, only once they are fully agreed and certain to then go ahead and actually draw them. And over a number of sessions, the number of folds they have to do is increased. And crucially, they do not get to see any illustrations. They're not allowed to use any external aids, pen and paper, or anything like that. So how can you represent these kind of folds? So naively, you would approach, most people would probably approach this task in terms of visual mental imagery. But if, I don't know, if you go ahead and do that, having no prior experience with that, this might be feasible up to the second fold. Sort of very talented people might be able to do it with the third one. But at some point, never mind how talented you are, you just can't do it anymore. It becomes too complex. So beyond that, you sort of need to identify more abstract properties, you need to introduce further distinctions, further structure. So implicitly, this task essentially is to transform a visual imagery task into some form of spatial reasoning problem by inventing a language for talking about this kind of stuff. So to give you an idea, this is sort of a very symbolic way of presenting it. Here we see sort of 3 times the same transformation of the 3rd double fold into the 4th nested fold. And on the top, this is sort of all in one color to sort of show what it would look like if you think about this as transforming one complex object. And I hope you would agree that this is sort of, it's very complex to see actually what the lines here are. Whereas if you think about it in terms of, you have sort of 3 more simple objects that are sort of composed into, that have certain spatial relations to each other. So essentially we have 3 folded edges. They're just folded one time. 2 of them are nested within each other. 1 is next to them. It's already, that's much more easier to understand. And then sort of one crucial insight in this whole domain is that actually you can just look at the tips of the open sides of those edges, because what's happening below here is that they're just sort of connected with sort of concentric arcs. And this kind of insight would lead to sort of an ability to mathematize this whole domain, but this is something that probably won't happen within the first couple of encounters with this. So for this case study, I had 7 pairs of participants, and the structure was like this. On the first day, they came in for an individual session to sort of make sure they actually understand all the instructions and so on. They imagine and plan to draw the second fold. Then on the second day, they were together with their partner. They had to imagine the 5th fold, and on the 3rd day, they had to plan to draw and finally draw the 5th fold. So I had about 4 hours of video recordings per pair of participants and a lot of stuff to analyze. So here you see 6 drawings of the of those pairs. 1 of them didn't get to draw actually the 5th fold. You can see some of these drawings, or maybe you sort of can intuitively see that some of those look like they could be correct and some of those don't. So for deeper analysis, I looked into this pair 1, the ones who did this drawing, mainly because this pair was really communicating well with each other. So they took this instruction to discuss until they are agreed and certain really seriously, sort of explaining how they understood it and how they think the other one understands it and so on, whereas the other ones were a bit more keen to agree with each other and get to the lunch break. So looking into this case with the creative names S1 and S2. So in the beginning, they started out, perhaps not really surprisingly, using loads of gestures. So we had things like deictic gestures, sort of pointing to positions on the imagined object or indicating folding directions. There were iconic gestures sort of representing actions, like literally sort of the folding action. Or here on the right, we see one of them using this kind of gesture to indicate, sort of to represent a folded edge. And these kind of gestures occurred lots and lots. So initially, sort of the first gestures that represent folds were sort of, starting with the first fold. You can literally represent that with your hands, right? Like this or like this. This is the whole structure of a sheet of paper that's been folded once in terms of the edges you can see. So we saw all these kinds of variations. But very quickly, they sort of canonized it and settled on using this one. And very quickly also, they started to use it compositionally, even though their language still was very simple and they were mainly sort of using deictic phrases of saying this one, that one, over there, and so on. So the really sort of the meat of it was happening in terms of their gestures. So you can sort of recognize this kind of double structure, this kind of nested structure, and so on. And this kind of reuse sort of went on as the folds became more complex. And this is including stuff what I would call a metonymic gesture, in that there is only sort of a partial resemblance anymore. So they keep reusing this kind of gesture. But now sort of we have like we have a doubly folded edge here. And they use the same kind of gesture to represent the closed side of it and the open side of it. So you really need additional contextual knowledge to distinguish this one from one which is flipped upside down, which in terms of gestures would look identical. So the resemblance has already gotten a bit more abstract, even with just their gestures. And they push this approach really, really far. So at some point they start using their hands together, and this is sort of as far as they could take it. This is them using 4 hands to represent or to talk about the nested side of the 4th fold, which you can see here on the right side. And then they sort of run into a wall, sort of, because they haven't really developed any kind of way of talking about it other than using their fingers to represent edges. And now they ran out of fingers. And so what happens at this point in the case study is that there is sort of a gradual shift to language and the relatively sudden proliferation of figurative language of all kinds of sorts. They start using metaphors, metonymies, sort of more literal figurative descriptions. They're making little jokes. The first metaphors they use, they're sort of local. They only describe sort of one aspect of the thing, and they're very ambiguous. Things like talking about a folded edge as an ellipse, which doesn't really make sense because an ellipse is a closed shape. But it sort of works for the moment, so that's why I call it scaffolding. Or things like calling something a sandwich if you have a nested structure that's surrounded by sort of 2 outer parts. But sort of very quickly, those first ambiguous metaphors are sort of being replaced or refined into clearer ones. So we get things like terms like wedge coming along, which sort of replaces the ellipse that we were talking about earlier. But they're still having real difficulties talking about this 5th fold, as you've seen it before. I mean, it's really complex. And at some point, they were really sort of running out of steam and just sort of chatting with each other, sort of a bit introspectively about sort of how their mental imagery of the thing appears to them without really having any kind of aim in the conversation. And one of them says, I can only imagine it if I ignore the connectedness, because I'm imagining it rather geometrically with open crocodile mouth, as it were, and there's an ellipse on top, there's an ellipse on top, and so on. So we have this description of the open ends of this sort of complex figure as a crocodile's mouth. And they continue chatting. This doesn't really play a role, but sort of a couple of minutes later, they just sort of, now this terms in the room, and they start sort of reusing it, and they gradually elaborate this into a kind of metaphor. So we get a dialogue like this. Is this like a normal folded crocodile? Exactly. It's a normal folded crocodile, and then we've got a rounded doubly folded, no, 2 nested doubly folded crocodiles. And building on these kind of compositional gestures they had earlier and the prior metaphors, they sort of slowly integrate all of this into this kind of crocodile language to talk about those sort of complex shapes. So we get here, this is the doubly folded crocodile, or as at some point they also start referring to the 3rd order crocodile. The mouth we already had earlier, they start using the term jaw for it. And then on the other side, there's a tail. And then ultimately there are jaws, there's a shoulder, there's a belly button, interestingly, because reptiles don't really have them. There's a hip, there's a tail, and so on. So all of this is integrated into this language, and using this language sort of ultimately enables them to plan the sketch and then to make the sketch without any kind of mistake, even if it's a bit wobbly. So now, if those metaphors played such a big role in them coming up with a way of representing those folds and talking about them, we have to ask the question, where did those metaphors come from, if we're interested in where the representations came from. And there's a couple of things to note here. First, there's sort of the role of the gestures, which sort of preceded them here. I mean, it's gestures in this sort of heavily visuospatial task, so it's perhaps not surprising that it's gestures here. Obviously, that doesn't necessarily have to be the case in any other kind of task domain. but here they were really prominent. And those gestures introduced a lot of distinctions that that weren't available to them in any form of sort of linguistic domain. They really struggled with it a lot of time. I mean, I compressed sort of, several hours of discourse into a couple of minutes here, making it look far more goal-directed than any of that happened. But those gestures sort of preceded and introduced a lot of distinctions that then those metaphors could sort of pick up on. And then there's the previous metaphors. So it wasn't like sort of an inside thing where suddenly they had this brilliant idea, oh yeah, it's a crocodile, everything makes sense now. But they had all these sort of other weird little terms, weird little phrases for it, which then ultimately got integrated into the crocodile. And it didn't really matter that it was a crocodile in the end, other than that was a good name for a folded edge, but that could have been a pair of scissors or anything like that too. And there are activities beyond folding or imagining, so beyond the task as such in a kind of narrow sense. And I think that's important because if you remember this kind of problem space perspective, there we really just have sort of states and operators that represent aspects of those folds and sort of some ways to manipulate them. So if we stay within this framework and ask where those things come from, a lot of things that happen here don't really take place in that kind of sort of purely in that world of sort of the narrow task analysis of what needs to be done here. Things like repetition, paraphrase, elaboration, sort of a lot of things that just happen naturally in social communicative situations. Asking questions, sort of effective regulation, like you see that the other person is a bit confused, and so you try to say it again in a kind of different way, or you make a little joke which gets you onto some form of tangent. Non-task related cognition, like small talk, mind wandering. I mean, like I said, the crocodile thing occurred to them in a chat that wasn't goal directed at all in that moment, but a few moments later they could make use of it. So we have to consider that when we ask those questions of where all those representations are coming from. And one further thing, if you remember the scheme from the outset, is that if we look at the gestures, so then we can view them as, especially if we have this sort of situation with pairs of people. So we have a communicative situation with more than one person, but I guess to a degree that would also be the case for a single person. We don't just have this world of the target representation interacting with our memories and so on, but we also have the environment, and we sort of externalize things by talking, by producing utterances, and also by way of these gestures. And they have sort of only partial resemblances. There's this metonymical thing going on. So I think it's important, and this is an original thought by me, it's important to consider sort of the interactive element, sort of beyond the target representation. Also, the actual target is there, or at least partially there. In this case, I mean, it's an imagery task, but still we have these kind of externalizations going on, and the other person is interpreting those, and so on and so on. Okay. A few final theoretical conclusions, very tentative ones, but nevertheless. So one point that seemed very important to me is that what I call sort of the cognitive economy, so the necessity of having to deal with sort of heavy mental resource limits, and the expressive economy, the necessity to deal with the limits of representational media, like having a limited number of fingers. This sort of drives the necessity to repurpose previous representations. So it's simply because they are available and other sort of more appropriate stuff isn't available. So I just keep reusing things, even if sort of interpreted literally, maybe isn't 100% appropriate, but especially in a communicative situation, the context sort of carries a lot of that carries a lot of weight there. And this having to repurpose things in terms drives metonymization. What I mean with metonymization is that sort of the full resemblance, which we could start out of as long as things were simple, gets pushed into being only partial resemblance. But we just sort of keep using the same symbol, especially because, you know, it's sort of established as a canonical thing already. And this metonymization in turn can sort of drive abstraction by sort of pushing things to be less figurative, purely out of necessity, and also allows for wider association in that sort of as soon as this sort of very literal resemblance is being removed, it could also sort of make me think of sort of more different, more left field kind of things. And one final point that I found interesting, because if we look at sort of anecdotal reports of people, you know, having some world-changing representational changes going on, like in the history of science or so on, those things are all very often sort of a bit dubious to us, and a lot of times people also aren't really sure that they can remember where those things are coming from. And I think if we look at a case like this, this starts to make sense. If we see that we, by necessity, start repurposing things which had a completely different original context when they appeared, then sort of looking at it in hindsight, we don't necessarily should remember this sort of original context, because in the end, it has become to be a completely different thing. And I've found that interesting that in this kind of scaffolding metaphor that's also used a lot in education as well as situated cognition contexts, the sort of one of the main aspects of actual scaffolding, namely that it's a temporary structure, is often not playing such a prominent role, whereas I think here that really makes sense, because sort of I come up with something for a communicative purpose in a moment, and when the act of communication was successful, the thing itself already doesn't really play a role anymore. Unless maybe sort of more or less by coincidence it gets picked up again in the future, but it doesn't really have to. Yeah, and that was sort of it, just to give you sort of a very brief impression. I mean, I could continue talking about it much longer, but I think it's a good point to stop. I thank you for your attention, and looking forward to questions or comments.